More information. For this project, we select 4 different types of shoes: running shoes, boots, flats, and sandals. Each shoe offers different level of grip, so we expect them to behave differently in the wet and dry surface. For the incline plane, we use a plastic surface because it is smooth and can help us to understand better the results that we can obtain.
My name is Gerardo Garibay, and I will be saying the table of shoe weights. The first shoe is the Uncloud running shoe. It weighs 280 grams. The Birkenstock sandals weigh 308 grams. Then the Doc Marten boots weigh 700 grams. And the flats weigh 170 grams.
Hi, my name is Arlene Garcia, and I will be explaining you and showing you the table of results of our experiment. In this table, we have 4 types of shoes. We have sandals, flats, boots, and running shoes. And for each shoe, we measured 2 things: the average angle on dry surfaces and the average angle on wet surfaces, at which each shoe started to slide down the incline plane. Then, using these angles, we calculated the coefficient of friction using the formula tan. Now the results. In the dry condition angles, the value goes from 29 to 39, which tells us that some shoes start to sliding earlier, while others stay in place for longer. In wet conditions, the angle generally increased, especially for boots and running shoes. And looking at the coefficient of friction, we can clearly see that the running shoes had the highest friction on both dry and wet conditions, 0.1804 and up to 1.0 when wet. On the other hand, sandals and flats had the lowest friction value, meaning they slide more easily. Now I will also explain to you how shoes creep to the surface. Here we have a graph that compares the friction coefficient of each shoe in dry and wet conditions. The key idea is that a higher coefficient of friction means the shoe has a better grip. Now the results of the table. First of all, the running shoes. The running shoes had the greatest grip. Why? Because their soles are made of soft textured rubber designed specifically to increase friction. Second one was the boots, also shown high friction on wet surfaces, likely due to their thick and durable soles. And last, sandals and flats, which had the weakest grip because of their soles. Well, they're smoother and not designed to prevent slipping. Something important to notice is that all shoes, without exception, change the friction when the surface was wet. Some increased their sliding angle, but overall, wet conditions made the surface less stable. This confirms that water significantly affects friction. And well, to close this section, the table of results and the friction comparison clearly show how the material of the sole affects or influences how much shoe slips. Running shoes had the best traction, while sandals and flats had the lowest. This supports what we've learned in class. Friction depends mainly on the interaction between the surfaces, not on the weight of the shoe. Thank you for your attention.
The results showed that running shoes had the strongest grip on both dry and wet surface, while sandals and flats slipped more easily. This difference comes from the sole materials. Soft texture rubber created higher friction, making it the most effective materials, while smoother soles produce less traction. A high coefficient of friction is ideal when stability and safety are needed. In general, we prefer a high friction coefficient because it provides safer and more reliable traction. Finally, the shoe's weight did not affect the coefficient of friction, since a friction depends on the interaction between the two surfaces and not on the mass of the shoe.
In conclusion, our results shows that friction changed depending on the sole material and tread design. Running shoes and boots has the strongest grip, while sandals and flats slip more, especially on the wet plastic. This confirmed what we learned on class about how friction depends on the interaction between surfaces. And something unexpected was how much the wet surfaces reduce the friction for every shoe. As a team, one challenge that we faced was finding a surface that worked well for every show, for the experiment and give consistent results. By communicating and dividing the task, we were able to solve problems and complete each step. Through this project we learned how friction works in real situations and how the teamwork improves the accuracy and the results. Thank you.